Z is not included. 0 is not included. Means ROC is 0 radius circle is excluded. Question number 2. Xn is 1, 2, 3, 4 with arrow mark here. Now by putting into the formula from -3 to 0, xn z power minus n, because 0, -1, -2, -3. Now I write direct answer. 4 plus 3z plus 2z square plus z cube is our answer. Entire z plane, but except z equals to infinite, means ROC is except this, all the radius circle except infinite circle. This is our complete answer. Third example of discrete finite sequence. Xn is 1, 2, 3, 4 with arrow mark 3, 2, 1. Limit is time range limit is -3 to 3. Xz is minus n equals to -3 to 3. Xn z. I write expression for direct z term. 2z square plus 3z plus 4 plus 3z inverse plus 2z inverse square z cube. This is our z transform answer. Comment on ROC. Entire z plane, entire z plane, but excluding two terms, 0 and infinite. If I put a 0 in it from this term, it become non-converse. Infinite means ROC is in between two circle, 0 and infinite circle. If right-sided sequence, right-sided means exterior of the circle, exterior of circle. Circle is decided by R max, maximum real part of the pole. Left-sided, interior of the circle, R min. If ROC include unit circle, system is stable. Now we discuss the property of Z, properties of Z transform. First property, linearity. In all transform, first we discuss the linearity. If x1n is z, x2n is z2, xz2, then a1 x1n plus a2 x2n is scaling as well as superposition. Homogeneity and superposition apply simultaneously. Result will be example an mod alpha is less than 1, an un plus a minus n u of minus n minus 1 equals to yn. xn is given to us. Then Z transform of this is we already discussed. ROC for this is this following linearity property. Next property, time shifting. Time shifting. In the time shifting, if xn equals to xz, then xn minus n naught is converted into this term. This term add this additional term due to time shifting. Next property, scaling. Multiplication or by z naught n. In the scaling property, xn z naught n is applied, then it is revised in this way. ROC also revised. ROC always calculated and last z expression because maybe pole zero cancellation in any condition. So at the last expression we can calculate ROC. That's why I am not comment on ROC in any scaling property. Special case of this is omega n xn equals to x e power minus n z. It is a special case of scaling. Now we discuss some equation and then move ahead. Xn is minus 1 power n un plus alpha power n u of minus n naught. ROC is given to us, which is in the range of 1 to 2. We want to calculate value of alpha and n naught is ROC in the range of 1 to 2. From first expression, ROC of this term is greater than 1 because it is causal and greater than 1. Second term is responsible for less than u of minus n naught. This is responsible for less than 2. Second portion of the ROC. First portion come from this. Second portion come from this expression. Means alpha is equals to plus minus 2. Maybe any value. Plus or minus. Whatever the n naught value does not affect ROC. Means shifting does not affect ROC. ROC is not shift dependent. Or we can say in this way, ROC is shift independent. It is shift independent. Now we move to next problem. Time reversal. In the time reversal, n is replaced with minus n, z is replaced with minus power 1, means x 1 upon z. We get the desired result. Means right hand signal is converted into left hand sided signal and vice versa. We can prove it. Un is z upon z minus 1. U of minus n is z inverse minus 1. Z transform of this is minus. Instead of using z inverse, with the z inverse we have final answer is 1 upon 1 minus z, with ROC is less than z. In this case ROC is greater than z. Just revise. Direct putting into the formula, z replaced with minus z, z of minus 1, got the answer. Next property, multiplication by n. Multiplication by n or differentiation in z domain. Differentiation in z domain. Xn is xz, then nxn is represented by this term on dz. Next property, accumulation. Accumulation is represented by k from minus infinite to n xk 1 upon 1 minus z inverse x of z. It is known as accumulation property. Accumulation is counterpart of integration in LT Laplace. Counterpart. Z counterpart is integration in LT Laplace transform. Z transform. Next is convolution. Convolution in time domain or discrete time domain is converted into multiplication in z domain. It is very useful property to solve convolution between two discrete sequences. Now we will discuss initial value theorem. Initial value theorem is applicable for causal signal as we discussed in Laplace. It is valid for causal signal. For initial value theorem, x0 limit z tends to infinite xz. We can calculate initial value. For example, I took an example 1 minus 3 by 2 z inverse 1 by 3 z inverse 1 by 2 z inverse. We want to calculate initial value of this expression xz. x0 limit x z tends to infinite xz by putting z inverse equals to 0, 1 upon 1 minus 0, 1 minus 0. Result is 1. Initial value theorem is completed with example, and now final value theorem. If xn is 0 for n less than 0, then limit n tends to infinite x infinite, final value theorem, limit z tends to 1, z minus 1 xz. It is final value theorem.